This is the CA250 screencast assignment by Group 14. In this screencast, we will look at hypothesis testing and in particular proportions. So when we met up as a group, we decided to test to see if 40% of people use diesel fuel instead of unleaded fuel. In this test, a random sample of 50 people were surveyed with a 100% response level and a significance level of 95%. We managed to gather our information by asking a random sample of 50 people how many cars in a random sample of 50 cars were diesel. As we were only asking for an opinion and we weren't gathering any personal information, we managed to avoid any ethical issues. So when we asked the people what percentage of people they believe drove diesel cars, we gathered the following information, which you can see below. We will use this information in the next slide to calculate our sample mean, which we'll use later on in our formula. So to find the mean, we add all the values on the previous slide together, which gives us a total of 1,695. We divide this by 50, which is our sample size, and this gives us 34%. We use the notation pi to represent our average mean of the totals, which we'll use later on in our formula. So by visiting a petrol station and observing the first random sample of 50 filling their cars, we found that 27 used diesel fuel and 23 used unleaded fuel. Therefore, P, which is our actual amount, is equal to the number of interest over our sample size. Our number of interest in this case is 27, as 27 is the number of people that use diesel fuel, and our sample size is 50, so this gives us 54%. So if we refer back to the question, to test to see if 40% of people use diesel fuel rather than unleaded fuel, we have to set an H0 and H1. So our H0, or our null hypothesis, is where pi is equal to 40%, and H1, where pi is not equal to 40%. So now we must decide what test to use. As it is a one-tail test, we must use a z-stat formula rather than the t-stat formula, because as the sampling distribution of P, which is our actual amount, is normal, therefore there is no need to have any degrees of freedom. So if we look at our z-stat formula now, we can now see it is P minus pi over the square root of pi into 1 minus pi over n, where P is equal to 54%, pi is equal to 34%, and n is equal to 50. We managed to calculate all these values on the previous slides. So if we look at the solution, we changed our percentages into decimal places. So the 54% became 0.54 and the 34% became 0.34. In the end, we end up with a z-stat value of 2.9854. This doesn't have much significance at the moment, as we'll have to compare it to a critical value to see if we can accept or reject our hypothesis. This is just the Excel verification of our formula to show that we used the formula correctly and managed to obtain the same answer. If we now look at the statistical tables on table 5, we now look for a critical value to see if, compared to our z-stat value. As we had a 95% significance level, we compared to 0.05 on the table. This gives us a critical value of 1.64485. We will then use this 1.64485 in our normal distribution curve and compare it with the z-stat value to see if we can accept or reject the hypothesis. So as we have our critical value of 1.64485 and our z-stat value of 2.9854, we look to insert these in the distribution curve. The 1.64485 would lie roughly along this line here, and our z-stat value is beyond the scope of this 1.64485. As it is an upper tail test and the 2.9854 is beyond the 1.64485, we reject our hypothesis as it is too far away from the mean.